this is question number 10. We are given P to be equal to -1, 2, 0, 5. Q is A, B, this is Q, and R is 11 and 15. Now they are asking us to examine if P is singular or not. When they say not, it means non-singular. So we have to check that. So P is equal to -1, 2, 0, 5. You find the modulus of P, which is nothing but determinant of P, which is -1, 2, 0, 5. You cross multiply 5 times a -1. When you go towards this side, we carry a negative sign, but we have 0 times 2. So this is going to be 5 into -1, which is -5, which is not equal to 0. So you conclude that since modulus of P is not equal to 0, this means P is non-singular. You have to specify that. Determinant is not equal to 0, so the matrix is non-singular. Okay, so having got that, next is given, this is part 2, given PQ is equal to R, we have to find A and B. So P is -1, 2, 0, 5. My Q is AB. My R is 11 and 15. So row with the column, multiply that. So -A plus 2 times B is equal to 11. 0 times A is 0 plus 5B is equal to 15. So this is 1 and 2. So from 2 you have 5B is equal to 15. You divide by 5. You get B is equal to 3. So you put B is equal to 3 in 1. You get -A plus 2 of 3 is equal to 11. So -A positive 6 is equal to 11. You push this to the other side. You get -A is equal to 11, -6, which is nothing but positive 5. So therefore A is equal to -5. B is equal to 3, A is equal to -5. So they just want us to get the values and we have got them. Now this is the next part of the question. They are asking us to state why QP is not possible. QP is not possible. Okay, so this is explanation. So order of P is what? 2 rows and 2 columns. 2 rows and 2 columns. Now order of Q is 2 rows, right? And you have 1 column. Okay, fair enough. So PQ is possible. Why? Because the column order, row order matches. Now we check for QP. Okay, so order of Q is what? 2 rows, 1 column. 2 rows, 1 column. Order of P, 2 rows, 2 columns. 2 rows, 2 columns. So you see that since the column of Q is not equal to the row of P, you can write order of column of Q not equal to order of row of P. QP product under matrix multiplication is not possible. Okay, so this they do not agree. Okay, you can put a into mark like this. So that's why the multiplication of QP is not possible, but PQ is possible. Okay, let's move to the next. Now this is the next question. We are given that OABC is a parallelogram with X is the midpoint of AB and Y is the midpoint of BC. OA vector is R vector and OB is S vector. It's actually OC. Okay, R vector and S vector. Complete the diagram. This is the first question. So we have been given the parallelogram. This is O, this is A, this is B, this is C. Now X is the midpoint. Okay, so I connect O with X, and then Y is the midpoint of BC, so I connect So this is the figure. So these two sides will be equal. These two sides are equal. Okay, probably I'll give one line here, one dash here, because I do not know the side here. But over here it's two dashes and two dashes. Okay, that's fair enough. Now the question is, we have the following: OA vector is R vector and OC vector is S vector. Now I want to get the value of, because the next question, see the next question, let me write the next question. Given OX positive OY is equal to K is a constant, R positive S, we have to find the value of K, right? So that is the next part. Okay, now there are a few things we need to observe here. Now, OABC is a parallelogram. So that means AB vector or the opposite sides are equal. AB is equal to OC and BC is equal to OA. Okay. Now what I wish to do is I would like to connect O with B. Now if I want OB vector is nothing but OA vector plus AB vector. But AB vector is equal to OC vector. AB vector is equal to OC vector because OABC is a parallelogram. So if I were to take this as 2, therefore 2 is rewritten as OB vector is equal to OA vector plus OC vector. Now OA vector is equal to R vector and OC vector is equal to S vector. So if I were to take this as say sum 3, therefore 3 is now OB vector is equal to R vector plus S vector. Now we have X as the midpoint. Okay, so I can actually connect X with A and B. Okay, so since X is the midpoint of AB, this means OX vector is equal to OA vector plus OB vector divided by 2, which means OA vector is R vector, OB vector is R vector plus S vector divided by 2, which is going to be 2 times R vector plus S vector divided by 2, which is nothing but R vector plus S vector divided by 2. This is OX vector. Okay, I'm just using basic algebra. I use this part of the space since y is midpoint of BC. So OY vector is equal to OB vector plus OC vector divided by 2. Now OB vector is R vector plus S vector, OC vector is S vector divided by 2. This is R vector plus 2S vector divided by 2, which is R vector divided by 2 plus S vector. This is my OY vector. Now this is given, isn't it? So therefore OX plus OY, OX is what? R vector plus S vector over 2, OY is what? R vector over 2 plus S vector. So I can club these two together. I take R vector out, I get 1 positive 1 over 2. I club these two together, I take S vector out, I get 1 over 2 positive 1. So this means 3 over 2 R vector plus 3 over 2 S vector. I can take 3 over 2 out. I will get R vector plus S vector. So this is OX vector plus OY vector. I take this as 4. I take this as 1. I compare 1 with 4. What do you see? K is equal to 3 over 2. So let me finish it off over here. Comparing 1 and 4. We see that K is equal to 3 over 2. This is what is required. Okay, you compare 1 with 4. Okay, so that is the end of this paper's review and learning, students. Please like, share and subscribe. Thank you.